Hello, my dear friends. Welcome to Sanjanvi online classes. And today we are going to discuss about electrical charges. This topic is in the first chapter of class 12th standard in CBSE related to physics. So we are going to discuss today about electric charge. What is an electric charge? So that particular point I am going to discuss today. This is the very basic. You can say that when we start learning physics in 12th standard, it's the basic component which is there in the first chapter, that is called electrostatics, electric charges and field. So here we are going to discuss about electric charge. Electric charge. So what is an electric charge? So actually when we go for the correct definition of an electric charge, we define as charge is an intrinsic property. Yes, intrinsic property. So this particular word is the key word, intrinsic. So intrinsic property associated means this property is associated with the smallest particles of matter, with the smallest particles of matter. Smallest, or we can call also as elementary. So charge is an intrinsic property associated with the elementary particles of matter. Particles of matter. Okay. So we all are aware that elementary particles of matter is an atom. Elementary particles of matter is an atom. Now, charge is an intrinsic property, means it is the property of the matter. Okay, property of elementary particle of matter. So it is inherent property. It's not that the property is being given from anywhere else, it is an intrinsic property. And we can say that the intrinsic property, charge is an intrinsic property associated with the elementary particles of matter, which is an atom only, and due to which it produces and experiences both. Produces and experiences, okay, what? Electric and magnetic effect. Electric and magnetic effect. Electric and magnetic effect. Okay, electric and magnetic effect. Electric and magnetic effect. So when we go for definition, we call that charge is an intrinsic property associated with the elementary particles of matter, due to which it produces due to which it produces and experiences both electric and magnetic effect. Now, Benjamin Franklin actually is the person. Benjamin Franklin is the person who introduced two types of charges. Benjamin Franklin introduced two types of charges, and those two types are negative charge and another one is positive charge. Negative charge and positive charge. And these two negative charges and these two charges, positive charge and negative charge, can be produced by rubbing, can be produced by rubbing two unlike objects. Like for an example, if we say, so it is amber and wood. The example is amber and wood. Amber and wood. Okay. So this is also called as frictional or static electricity. This is also called as frictional or static electricity. Right. So this type of electricity produced is called frictional or static electricity. So what happens when we say that the electricity is produced? Actually, it is transfer of electrons. In this process, what is happening? Transfer of electrons. Transfer of electrons. Actually, the charge is an electron. Charge is an actually electron or number of electrons. Now the SI unit of charge is Coulomb. The SI unit of charge is Coulomb, which is denoted by capital C. Okay, Coulomb, named by the scientist. And as Coulomb is also a very big unit, so generally charge is being expressed in micro Coulomb. Okay, micro Coulomb, pico Coulomb, nano Coulomb, like this. Let us go to next topic, that is called conductors and insulators. Now, what is called conductor? Conductor. So these are substances or objects which allow the passage of electricity, electricity. Actually, we can say that substances or objects which allow the passage of electricity easily, easily, without any resistance, without any resistance. So the conductors are those objects or substances which allow the passage of electricity, means the electricity is being allowed to flow in that particular substance easily without any resistance. And when we talk about, you can say, insulator, then it will be the just opposite of this one, just opposite. So insulator, we can write that substances or objects which do not allow, the passage of electricity easily. So substances or objects which do not allow the passage of electricity easily. These type of substances produces enough resistance. Okay, so a high resistance. These substances produces high resistance, to the passage of electrons. So if we go for example of conductor, so all metals are conductor. Metals may consist of copper, okay, copper, aluminum, silver, etc. Even water is also good conductor of electricity. Insulator, objects which do not allow the passage of electricity easily. So you can say that plastic rod, nylon, okay, rubber, plastic rod, nylon, rubber, etc. So this is actually the definition of conductors and insulators. Okay. Now we will go for basic properties of electric charge, which is very, very important in view of examination or in view of board exam. It is very, very important. Very, very important. So the properties of electric charge, first one, additivity. This additivity says that charges, first of all, charges are scalar. Okay, charges are scalar quantity. What is called scalar quantity? The physical entity which is having only magnitude and no direction, that is called scalar. The physical entity which is having magnitude and direction both, that is called vector. So there is a word which we all should know, and that is called scalar and vector. Okay, scalar and vector. So additivity In that also we can say that charges are scalars. Okay, charges are scalars. Charges are scalars and they they add up like real numbers, like real numbers. So if there are many charges Q1, Q2, Q3, Q4, charges are denoted by capital letter Q also and a small letter q also. So Q4, then it is going to Qn. It means total charge Q will be equal to addition of all the charges Q1 plus Q2 plus Q3 and plus Qn, if n number of charges are there. Second property is conservation of electric charge. This is the second property. Conservation of electric charges. So the total charge of an isolated system remains conserved or constant. So we can say that total charge of an isolated system remains constant, or we can say as conserved. Constant or conserved. It means initial and final charge of the system will be same. Initial value of the charge or final value of the charge, both will be same. There will not be any changes. Means if some 20 Coulomb charges we are utilizing for producing electricity, and at the input end we are giving 20 Coulomb, at the output end also we will be getting 20 Coulomb. So third, quantization. It is called quantization. Quantization of electric charge. This states that electric charge is expressed as integral multiple of electrons. So expressed as integral multiple of number of electrons, integral multiple of so expressed as integral multiple of electrons, that is called quantization of electric charge. It means Q is equal to N into E, and as n is an integer, so we can write it as N is equal to plus minus Ne, plus minus Ne. So if N is negative, we can say that the charges is a negative charge. Charge is a negative charge. If N is positive, the charge is a positive charge. We know that the value of E electron is having a charge of 1.6 into 10 power of minus 19 Coulomb. Okay. Most of you are already aware. So this value you need not to remember in the examination. In the examination already all the values will be given to you. So no need to worry that I need to remember the value of E, uh, charge of E, mass of E, no, electron. It will be already informed to you, means through in question paper itself it will be given. So there is no need to memorize it, but due to more practice, certainly you will be able to memorize it. Now when we come for Coulomb's law talks about the distance Coulomb's law is talking about the force between two charges. If the two charges are placed a distance d apart from each other, then through Coulomb's law we are in a position to find out the force exerted between these two charges. So the force of attraction or repulsion. In charges, when we were discussing about charges, we did not tell you that when basic properties of electric charge. So like charges repel each other and unlike charges attract each other. Means positive and negative will be attracting and negative will repel, positive will repel. So this also we need to remember. So the force between two charges is directly proportional to the product of the charges. And the force between two charges Q1 and Q2, which are at d distance apart, is inversely proportional to the square of the distance between them. Square of the distance between them, because we have put here d, otherwise many places r is put, so it will be square of the distance between them. And then combining these two, 1 and 2, from 1 and 2 we got F is directly proportional to Q1 Q2 by R square, and we can write as F is equal to K Q1 Q2 by R square, where K is proportionality constant. K is proportionality constant. Proportionality constant, and its value is 1 by 4 pi epsilon 0. The value of K is 1 by 4 pi epsilon 0, which is equal to 9 into 10 to the power 9 Newton meter square per Coulomb square. Whereas epsilon 0 is called permittivity of free space. Permittivity of free space, and its value is 8.854 into 10 to the power of minus 12 Coulomb square per Newton meter square. Now comes the definition part. So the definition part, when we say, so we can say that electrostatic force of attraction or repulsion acting between two stationary point charges in vacuum is directly proportional to the product of the charges and inversely proportional to square of distance between them. To square of distance between them. So this particular definition of Coulomb's law is very, very important, because in examination it will be asked there, compulsory questions will be there. So f in vector form, we can write it as, this is called vector form. So 1 by 4 pi epsilon 0 q1 q2 and mod of r square and r vector. So that this is there. So this is in vector form. So I feel that the basic concept of electric charge is very clear to all of you. Once again, we already discussed about basic properties of electric charges. Before that, we discussed about electric charge. Let me tell you once again that electric charge is an intrinsic property. Please do not forget to write intrinsic. Intrinsic property associate with the elementary particles of matter. Elementary particles of matter is an atom, and due to which it produces and experiences electric and magnetic effect. So the sentences are very accurate one. We need this sentence should be written, okay, grammatically it should be correct, but the key words like intrinsic property, elementary particles of matter, produces and experiences electric and magnetic effect. So these things are compulsory to remember. And who discovered charges? So Benjamin Franklin discovered charges. He only introduced two types of charges, negative charge and positive charge. Negative charges are repelling each other, or like charges repel each other, unlike charges attract each other. Okay, and this is called frictional or static electricity, which can be produced by rubbing two unlike objects. The SI unit of charge is Coulomb, and as it is a very big unit, so small units like micro Coulomb, nano Coulomb, pico Coulomb is used. Conductors and insulators. So conductors are those materials which allow passage of electricity without much resistance. All metals, water are the examples. Insulators are those substances which do not allow passage of electricity easily, like plastic, nylon, wood, rubber, etc. Now basic properties of electric charge. So that is additivity, means charges can be added like real numbers. Total charge remains constant, so that's why all the charges can be added together. So total charge Q is equal to Q1 plus Q2 plus Q3 plus Qn. Conservation of electric charges. It is called total charge of an isolated system remains constant or conserved. Okay, the charges will not. If in input I am giving 20 Coulomb of charge, I cannot get 30 Coulomb of charge or 50 Coulomb of charges. Maximum 20 Coulomb of charges only I will get, or even less. Third property is quantization of electric charge. Means that electric charge cannot be in fraction. It is always expressed as an integral multiple of electrons. So that's why the formula of Q is becoming plus minus Ne, as N is an integer. Going to next one, Coulomb's law. Coulomb's law talks about the electrostatic force of attraction. Yes, it talks about the force of attraction or electrostatic force of attraction between two charges kept at a distance apart, that is R meter. Then the force exerted between these two charges Q1 and Q2 will be directly proportional to the product of the charges, and the force between these two charges will be inversely proportional to the square of the distance between them. Combining both of them, we are getting the force as Q1 Q2 by R square into 1 by 4 pi epsilon 0. 1 by 4 pi epsilon 0 is K, which is called permittivity of free space, and K, you are knowing that it is proportionality constant. Simultaneously, the value of epsilon 0 is 8.854 into 10 to the power of minus 12 Coulomb square per Newton meter square. So, for the next topics in that same chapter, like electric fields, then further Gauss theorem, and further uh, other topics are also there. So those topics we will have a discussion in our next classes. So thank you very much. If you have liked this video, then please subscribe and share it with your friends. Thank you very much.